Hey everyone. So last week we talked about what did we talk about? We talked about linear equations, solving linear equations in one variable. And the continuation, the natural continuation of this is to talk about linear functions in one variable as well. I don't think you will encounter any two variable functions. As we've done earlier, we will be covering some theory, just some very brief notes about stuff, some facts, some useful tricks, and some useful cues. And then we will be doing lots of exercises, in fact, as much as we can for today. So I want to start with this type of question. It talks about a roller coaster car. Very cool, by the way. Yeah, it's at the bottom of some hill, and it's 15 feet above the ground. Maybe I can try to draw a roller coaster for you. Big wheels. Okay, that's not how you draw a roller coaster. Okay, that's a very good drawing of a roller coaster. And this is the ground. It's 15 feet up. And it rises 8 feet per second. So when so at the first, I don't want to say at the first second, but at the 0th second, its height is 15. That's obvious. That's what the drawing tells us. Very accurate drawing. And then after 1 second, it rises by 8 feet. So what should be its new height? That's a question for you. 23. Yes, actually, when I did it the first time, I was like 22, but I can't do 15 plus 8 quite well from the first time. So it's 23. Okay, what about the second one? Second. What's the height then? Going to be this one.
31?
Yeah, 31. And the final one? Yeah, 39. Okay, so it goes on and on. There's a common pattern. It starts at 15 and it increases by 8 with each second. So how do we model this? Well, maybe I should just give it out. So you start with 15 feet, and with each step, so 15 plus 0s is 15. 15 plus s is 23. 15 plus no, that's wrong. That's not correct. Okay, this is not accurate. So what I want to say is you take a certain step with each second, and this step is 8 feet. So that's how it works. So it's 15 plus s times 8. Yeah, it's easy to just say that this is going to be the answer. Now let's talk about why this makes sense, at the very least. And for this, I've prepared some stuff for you. I think we have more people. It's very good. So I want to, before I talk about what a linear function is, that's the goal of today. Hi. I would like to talk about what a function is in the first place. So a function is just it's just something that you give it an input and gives you an output. So you give it an x, it gives you a y. And this is very important. So I said 1 because I think it is very important. If it gives you more than one, if it outputs more than one number, then it's problematic. And if you give it more than one number, well, you cannot. It's defined to take just one value. So you can imagine a set that has all the points with which we can plug in, and a set which has all the points which we can get out of this function. And I have some letters for them here. Before that, how does a function work? Well, you plug in x, you get y. That's it. You plug in x, you get y. That's what a function fundamentally is. And there's something called the domain of f. And that is just the set of all possible input. So in this very, I don't want to say abstract, but this example where we don't know much about the behavior of this function, can you tell me what the input is going to be in that case for this drawing? What is all possible input? Can you point them out? I think I can if I'm holding. So I'm pointing them out. These are the 3 points in your domain. That's really what it is. And similarly, there's something that we have. It's called the range, and it's just all possible output. So I thought I would start with this very brief introduction because we will use this later on. So the domain is the set of all possible input. The range is the set of all possible outputs. And now, since this is not the core focus of our discussion, I would like to now start talking about what a linear function is. So this is really what we're going to be using to solve the problems for today. So we start with a function that looks like this. We know that a function is something you plug in and something you get out. So in this case, you see this expression, right? It's an expression where you plug in x and you get out y. For example, you can take m to be 1 and c to be 0. Then it's just y is equal to x. Now, if you want to plot this, it would be very simply plotted as follows. And the reason for that is very simple. So this is 1, and that is 1. So one step on the x-axis is 1 step on the y-axis. Minus 4 steps on the x-axis are minus 4 steps on the y-axis, if I drew this correctly. And so on and so forth. And so fundamentally, this is just what a function is. We plug in values, we get out other values. This is how you plot this relation. Now, going back here, well, there's of course the question of why it is actually linear. Why do we call it a linear function? If it's just, it could be just any function, right? Well, yeah, it's just represented by a line. That's why. So we credit the name to the graphical representation of it, more or less. And other functions are usually more complicated, but this is in the nicest class of functions. So later in the course, we'll talk about such functions like, for example, quadratic, and I don't think, and there are also some other functions, but this is the simplest type of functions. If you really master this, you can take the skills and go on to do more difficult functions, you know. So that's good. Now, here's what I want to say. First, maybe let me write this. Linear, it looks like. That's the reason. So a linear function is determined by 2 things. It's determined by its 2 constants. I just wrote down here. Okay, this is obvious to say. Not obvious. This is easy to say, but it doesn't really give you any info. So this m is called the slope. Or you could think of it as the rate of change of y with respect to x. So here, in this graph, this is the graph of y is equal to x. So if you, the same point in x is the same point in y, that's not too difficult to see. But I could, for example, take another function. Let's say I take 2x. Then how does it look like? Can you tell me one point that will be on this function? And by a point, I mean an x coordinate and a y coordinate. So choose a number x, and tell me what the y is going to be.
1 and y is equal to 2.
Amazing, because 2 times 1 is 2. The last time I checked. Okay, can you give me one more point?
10 and y is equal.
Yes, but can you give me a smaller point? Because I don't have enough space here.
So 3.
3. Okay, great. So 3 and 6, right? Okay, that's amazing. That's very good. So 1 and 2, I'll plot this. So I'll go one step on the x-axis. Have something in the chat. Oh, sure. Yes. So I'll plot this. So this is, by the way, a graph of x with respect to y. So I put the x value here, and I put the y value there. The y value there is understood as the output of the function, more or less. So I go to x is equal to 1, and then y is equal to 2. That's the first point. And then I do 3 and 6. So let me do 3 and 6. I'll remove these numbers because they're a bit distracting. I hope that's okay. So 3 is here. Okay, can you choose a smaller number than 3? Because I have to draw a fixed one. So 2, 4. 2 and 4. Yes, yes. Okay, thank you. Thank you. So maybe I should have taken that into consideration. So 2 and 4. Okay, and this is, I don't want to say this, but I think it is obvious that if you have 2 points and you draw the line that goes through them, that's not the line that goes through them. So if you want to draw a line, you only need 2 points. Is this obvious? It should go through the x-axis. Okay, please. Yes, almost. So that is something. And about this function, we can say that with each step in x, we move 2 steps in y. So that is the first thing that determines the function. It's a slope. And so in this case, the slope is 2, because it's the rate of change of y with respect to x. That's how we conceptually understand it. Now, how do we compute it? How do we compute the value for m? Well, it's not that difficult. So it's the change. Look at the change in y, and then you divide it by the change in x. That's really what it is. Nothing too sinister. Okay, how can we measure it? For example, here you guys chose some 2 good points. You were the ones who chose them. I did not give you any instructions regarding that. So it was 1 and 2, and 2 and 4. So maybe we can look at the change in y divided by the change in x and see what happens. So the change in y, how do we understand it? Well, we just look at the change in distance. So this amount has changed. This is 2 steps. No, it's not. Yes, it is. Okay, it is 2 steps. I don't know how to count. Amazing. So it's 2 steps. And then, yes, exactly. On the x-axis, we've just moved one step. So maybe I'll write it in green, I'll write this in red, because color coding is important. Okay, so we know that the slope is 2. It makes sense, at least for our function. And the reason why this works is because if you choose any two functions, the rate of change is the same. It's the only function who has a constant rate of change. So it's like if you take the average, it's the average function. That didn't make sense, so please ignore it. But okay, again, if I have 2 points, how do I find it? Okay, there's a formula, and we can actually make sense of it. So in this example, we did 4 minus 2. You can measure it. So this you can measure as, so this is 4, this is 2. You can do 4 minus 2. And you can also, in the denominator, you can write 2 minus 1, because this is 2 and this is 1. And more generally, if you have any two functions, what you can do is you can choose, say, any two functions. No, I mean any 2 points. So if you have any 2 points, you can just choose 2 coordinates, 2 x coordinates and the 2 y coordinates, and compare them. So in this case, in our case here, just to signify it, 2, 4 is equal to, for example, x1, y1. And 1, 2 is our x2, y2. And then you might ask me, well, okay, why did I choose the opposite? Why isn't this x2 and this x1? I want to change it. So maybe we have this idea, but it actually doesn't matter. And you can check this. So I want you to check that this is true. Or maybe I'll just say it. Okay, very briefly, we just multiply this by -1 and multiply this by -1. Then -1 divided by -1 is just 1. But at the same time, you've changed the signs. So that's how it's done. Okay, so that is the first defining property of any linear function. It's the slope. And the second property is the intercept, the y-intercept. And why did I say the y-intercept when I have not explained what this thing is? Because I made a mistake. No, just kidding. So I have this function here. It's y is equal to 2x. But then what if I want to move it up or down? Now, I want you to notice that this is the output, right? And for example, if I add a 1 here, maybe that's the wrong pen. If I add a 1 here, then my whole function just gets shifted 1 step up. Is this okay? If I do this 2 steps up, then it shifts 2 steps up. If I do a -4, then we just go back to our original position. We go down 1, 2, 3, 4 steps. So I want you to see this C as a way of controlling. Okay, that was not right. A way of controlling the functions. Like you give it the freedom to move around. So if we just say, let's say y is equal to 2x plus c, then we have an infinite number of functions that we need to determine. And if you choose a c, you get a certain function, and that's what determines. That's what really determines it. So that's a good visual image, I hope. Oh, look, now it's going through the origin. I'm so happy. So the constant, as I've hinted, probably, it's equal to the function at 0. Now, why is this true? Well, let's see. y is equal to m times x plus c. By the way, I hope that's okay if I just write, I'll just do like this, y of x. This is non-standard notation. I don't think it's common, but y is a function of x. So why not write it like this? So we plug in x into y, we get out an output y. That's how it works. Now, clearly, just by looking at this, let me maybe point at it because I'm not that tall. If you just put in x is equal to 0, so y of 0, it's equal to m times 0 plus c. So it is equal to c. And that's what's so nice about it. It's a very nice and short proof, I would say. So f of x and y are used interchangeably. I hope that doesn't cause you any confusion. So that's the second defining property of any linear function. It's that it has a unique slope and a unique y-intercept. Now, why is this a y-intercept? Because graphically, it's how many steps you go up. I want to move this function once again, but I want you to focus on the y-axis. So focus on where the graph intercepts the y-axis. So this is when we move it one step up. This is 2x plus 1. Correct? Okay, I'll just remove it anyways. This is 2x minus 3. And maybe you will tell me what this is.
Plus 5.
2x plus 5, yes, exactly. Because you just count up 5 times and then that's it. And how about you plug in x is equal to 0 into 2x plus 5? What do you get?
Y equals 5.
Exactly. So that's how it works. And this is the point. And by the way, this is the point where x is equal to 0. This point. Yeah, so I know this might be a bit obvious, but it's very important to go back to the basics. So these are really the two defining things about linear functions. And with this, we can actually solve any linear function problem. So why not start? So let's start with some exercises. So if this is the function, then what is the value of f of 5? Now we've talked about how a function is something which you give an input and it gives you an output. Now, if I have f of x here equal to 2x minus 1 divided by 3, then the way I would do this for this function is I would remove x for 2x. Why? I know we spend a lot of time in the 2x example. But so you just remove x and plug in 5. Remove x and put 5.
So it's like 2 times 5, it's equals 10, 10 minus 1.
Exactly.
9 over 3, it equals 3.
Exactly.
So that's 5. So it's c equals 3.
Exactly. So that's not too difficult. That's just plugging in values. And maybe we'll do, okay. So that was the note I was supposed to leave to you.
Shit.
Yeah, so I was writing, so I solved most of the questions and I looked at which skills you need to know and facts you need to know for the exercise. And so I used the introductory part to tell you all you need to solve questions like this. So indeed, if you have g of x is equal to minus x plus 8, you just remove x and put your value for it, which in this case it's 0. So that's not too difficult. Do you know what the answer is going to be? 8, right? 8, yeah. This is, so far, it's not too tedious. Okay, now we have some graphs.
Oh shit.
Yes, so we have a line that's graphed in the XY plane. And there's a model between the number of miles and the total cost in dollars. So I'll ask a very specific question, and that is, what are we inputting here? What is the input?
What is
Can you see the problem? Maybe I should do like this.
line?
You guys know what the input is going to be? It's not a number. If you want some hints, it's not a number. So we have a relation. We're inputting something. Dollars. Are you sure? Okay. But it's a good start. So you have a cab ride, right? You get into the cab. You drive for a certain number of miles, and then you have to pay a certain amount of dollars. So you cover the miles first, and then you pay the dollars. And so in this case, the input is the number of miles. And for convenience, it is labeled as X, as we've acquainted ourselves. And the output is in dollars, as you've said, in Y. So now we have some basic understanding of the problem, and it's asking us what's the cost for each additional mile, just by looking at the graph. So that's what the question is asking. But in reality, it's just asking you to compute the slope. Because this is a function where you have the number of miles, this is the number of dollars, and it's equal to
6.5.
Hmm?
It's like the number of miles traveled by Y. It's like 6.5.
6.5. So are you
Below side.
6, 7, 8, 9, 10? What do you mean by 6.5?
Oh, okay. So it goes like.
So so here you need to extract the points and see how it changes. Here you have 1, 2, 3. I hope I can still count. So 0 and 3. This is the X coordinate, and that is, hi guys. And that is the Y coordinate. So we've just talked about something which is the y-intercept. I just talked about it. You guys remember it? What it is? You know what the y-intercept is?
Yes.
What is it?
The y-intercept in this equation?
Yeah,
I didn't see it. Let me see.
3. So in
Yeah.
that case, this will be the constant for our linear function. So our linear function looks like y is equal to mx plus c. The constant here is 3 because we started the origin and moved it up. You were not there for this part, but it's fine. And the slope is the rate of change. It's how much it's changing. Now, if you want to compute it, we would like to choose 2 points at which we can do so. And here you actually have a lot of points. I think you have infinitely many points, but it's about how you can choose the nice ones. So here, I think. 5 tenths. I don't think so. But this is the point.
1 and 5.
1 and 5. Yes, okay, that's 1 point. So actually, if you like every single one of you can choose a point, then we wouldn't run out of points. So that's very interesting. It's 1 and 5, as you've mentioned. Now, how do we compute the slope? Yeah, it's this one, right? So yeah, or y1 minus y2 divided by x1 minus x2. Maybe I'll copy it and paste it. Not the whole thing, but we are. And I think it is good practice to keep this with us as we go throughout the questions. So I'll choose the one with y2 because I guess it's nicer. And this is the second fact that we'll need to solve the exercise. Well, actually, any exercise in this category of exercises. I'll keep this and I'll copy it as we go. And now if we want to compute the slope, we have 2 points. So it's just very simple. So I plug into the expression. Here's my pen. So M is going to be first off, my first point is 1 and 5. So that's x1, y1. My second point is 0 and 3. So that's x2, y2. And then I can plug those in. Yes, so 5 minus 3 is y1 minus y2, or I mean, it doesn't matter. We just showed that it doesn't matter. I'll take 5 minus 3 because it's positive. My preference, but I have to take the other ones in the same order.
1 minus.
Exactly. So 1 minus 0. I mean, in this case, this will be x2 and this will be x1. You want to stay consistent with the formula. Okay, 5 minus 3 divided by 1 minus 0, so that's 2 divided by 1, so it's 2. Yeah, so with each step you go with each mile you pay $2 more. Do you think that's fair?
What is it?
$2 per mile. You think that's fair? I don't know. Seems like a lot. So it's $2, and if you're on the SAT and you need to solve this really quickly, just make the quick observation that was done by I don't know what your name is. Stephanie. Nice to meet you. By the way, I'm Omar. You guys have not seen me before. So okay, so as Stephanie just noticed, she just found the closest point, and then it's very nice because then the denominator is going to be 0 because you only took 1 step, and then you look at it and the change was 2 steps. Then you just say, okay, this is going to be the solution. With each mile, the change is $2. So that's one way to approach it. Now let's
Or plug it in this.
or plug it on decimals. Sure. I mean, in the exam, practically, this should not take you more than 3 seconds. Okay, I'm exaggerating. I'm a math major.
It came this way, but if it's more complicated, then decimals.
Yeah. So here we're going at a very slow pace because we really want to make sure we understand everything. I have a certain analogy for this. I always say that if you want to run for 10 kilometers in 1 hour, you need to first learn how to run 10 kilometers.
Yeah.
So that's why just running the 10 kilometers, and then maybe we'll work on the timing later. And now this is a function. This is a table of functions, of values. I think I'm obsessed with the word function. We can look at the transcript for this lecture, and maybe we'll see how many times function in. That'll be very funny. I think somebody's waiting in. So back again. X and f of x. I'm just writing them in larger form because I don't think they're that clear. 3 and 13, 5 and 21. Now, can somebody tell me what the rate of change is here? Just looking at it very quickly. What's happening with every 2 points?
Increase to
Increases. Okay, so we move 2 points here. And how many points do we move on the other side? 8, yeah. 13 minus 5 is 8. Okay. And then I move 2 more steps.
And 8 again.
Then it's also 8. Okay, so if I move one step, it's
4.
4, right? This is obvious. Okay, it might not be. I'm just making sure that it is. So in this case, our rate of change, our slope, our m is going to be 4. And now we just need to determine the constant, which is the starting point for our function. 1. Are you sure?
Or 5.
5. Let me see. So maybe I'll bring this in. So this is what we will always use. I forgot to copy it, but here we are. I've copied it. Everything's good. Change in y divided by change in x here. The change was 4, which is 8 divided by 2. Amazing. Then the constant is just the value for f or y at 0. At x is equal to 0. So if x is equal to 1 is 5. At x is equal to 1, it's 5. Then at y, yes. So so you are right. It is 1. I think I was confusing it because he said 1, and I thought you were talking about domain.
No.
Yes. My laptop is not going to survive for long. That's a shame. Okay, but we will continue. So if we want to find the value of the function at x is equal to 0, we just go back at x is equal to 0. And we know that the function changes with each step. It changes 4 points. So I just go back to the point which I add 4 to get 5. And that's just 1. So I have my solution. It's 4x plus 1. My equation is just y is equal to mx plus c. I hope that is clear. So that is good. I want to do this problem. That one. Copy this. So I like this problem. I think we should do it. Now we have a function g, and this function g is equal to 5x plus a. So our problem here is with the y-intercept. Is this clear?
Yeah.
Yeah, that's good. So this is of course because if you plug in 0 for x, you get a. So that's the y-intercept. Now it gives you one fact, and that is g of 4 is equal to 31. So how do we combine these two facts together?
You just put 4 plus a equal 31.
So you're saying that g of x is equal to 4, but g of x is also equal to 5
Yes.
times x plus a, and then for x I just put 4.
Yeah.
Okay, that's great. That's actually the way to do it. 5 times 4 plus a, that's 20 plus a,
20 plus A, so.
and 20 plus a is 31.
11 or 31.
So a is 11.
So A is
That's amazing. That's just what we were doing last Monday. Yeah. Yeah. It's not too difficult. And let's look at some more questions.
شوف 31,000.
This is a good question that we can do without lifting the pen. So I have my pen here. And if we have the conceptual understand, okay, maybe I'll just use my pen to recall the previous part, which is this one. But okay, then I'll remove my pen, and then we can do it without the pen at all. So here, these are linear functions. You have the slope, and you also have the constant.
Okay.
So just by reading the problem, can somebody tell me what the rate of change here is?
C.
C.
Yeah, see.
The rate of change is C.
I thought you were.
No, I wasn't asking for the answer.
50 cents.
It's 50 cents, right?
Yeah.
Okay, so that's good. So we know it's not going to be this one or that one. So it's probably A or C.
Yeah.
A minus.
And A is minus, so it doesn't make sense.
Well, actually, so then it's actually the only one. So maybe you are right. But then also at the same time, we focus on the minimum hourly wage, which is $9.25. So there's always, in these type of problems, there's always a constant and a rate of change, and you need to link those two. So you see, you spot this, you start, there's a starting value, there's an initial value, there's an initial cost, there's something that's starting, and that's usually the y-intercept, that's usually your C that you're looking for. So I hope you can see this. Yeah, and this is also clear, right? We know. Okay, I don't think I chose the answers. This is also
Actually, I didn't get this question.
okay. So maybe a recap. We have a rate of change m, and we have a constant that is some sort of starting point for us. So here, do you know what the rate of change is? Just read the statement. It says that the minimum hourly wage was $9.25, and it increases by 50 cents for the next 5 years. So what is the rate of change in that case?
Change in this case would be like 10. No, it's like 970.
So it's actually, in this case, it's so you're not wrong. So what you just did is you computed the value of the function for the first year.
Yes.
Yes.
But they
But then-
like in the first year and completed to next
But
5
then
years.
with every year, it's changing by 50 cents.
Change it like less or increase.
It's increasing in this case because
But every year it's changed.
yes, it's increasing. That's what the problem tells us.
Okay.
And then because it's increasing, that's our rate of change, and it's positive. So we know that this is the only function which has a positive rate of change. Positive, and also it's 50 cents, so that's important. And you can also confirm this guess by looking at the y-intercept, or you could say the minimum hourly wage, which is actually at x is equal to 0. Or in other words, it's at the year before the first year. It's like the base, so that's why we start from 0 as well. I hope that is
Yes.
good.
So much.
Yeah, of course. So, and this is also clear. I don't think we need to lift the pen to do it. What do you think the answer should be? Why? B. Yeah. Would be B. That's very simple because it's literally what this set of facts here is telling us. So y is equal to 0 is C, and we know that our any function, any linear function can be written as y is equal to mx plus c. So if the rate of change or the slope is 3/4 and the y-intercept is 3, then we have our function, positive 3 actually, so not just 3. So that is the solution. Just look at the problem, we read it, and it's a free point. So that is the last exercise in the easy category of this skill. Then we will do more difficult problems. Now, again, the classification is by the College Board question bank. I don't say that it's easy or difficult. I don't want you to feel like I'm judging you. So we have this oxygen placed inside